So if you draw for minute, if you draw for that irreducible representations for ammonia, let's say this is C3v point groups. So characters will be 2, that is E, 2 C3 and 3 sigma B, and ammonia will look like this. Ammonia. So number of unshifted atoms. This is for irreducible representations. That is given to you. Now for class I am taking this. So actually this is given in the questions. Number of irreducible unshifted atoms E, then all the power, and C3, if I rotate C3 then 3 will change, so 1 will remain unchanged. Sigma B, then at 10 will pass by cutting the 2, because sigma will always pass by cutting, means here sigma is cutting, will pass by cutting hydrogen and nitrogen. So these two will be not shifted, these two will shift, so unshifted will be 2. And XYZ, this is that, or we can say that characters of E is how much? That is always 3, and C3 0, and 3 sigma B. B is always 1. So we multiply 12, 0, 2. So this is the irreducible representations in 3n coordinates. Okay, so this will given to you in the exams. How it will given? That this will given here, that irreducible representations given that 12, and this is 0, and this is 2. It will given to you, and they ask, and also given, this also given, that is E, 2 C3 and 3 sigma B, and here 3, then 3 classes, A1, A2, that is E, because here 1, 1 and 2, 2 means E. Okay, and this is 1, 1, this is always 1, 1, and if I draw here 1, then there is -1, and this is 0, then it will be -1. Okay, so these things is given to you. Now they ask that to calculate the irreducible representations. So from these irreducible representations, we have to calculate the irreducible representations. The formula for irreducible representations is what? Order of the groups 1 upon H, Xi, Yi, Zi, where Xi is character of irreducible representations, and Yi is characters of irreducible representations. That these are the irreducible representations, characters of irreducible representation. These are the characters of irreducible representations, and Zi is any coefficients of elements. What are the here? Coefficient 1, coefficient 2, here coefficient 3. Okay, that's, we use this formula and we will get the irreducible representation. Let's talk about irreducible representation. First we will start from A1, then what we have to use this formula 1 by H for ammonia, that is C3v. So order is 3n, where n is 3, so that is 2n, order is 2n. So here n is 3, so 2 into 3, that is equal to 6. So here 1 upon 6, and Xi is how much? This Xi means reducible representation, that is 12 for E, 12, and that is into this, the irreducible representation for E is 1, 1, and for Zi this is 1, the coefficient is 1, that's a 1, plus, if I talk about this is for 1, and next I will move for this C3, that is 0, and this is 1, after that coefficient is 2, and next this is 3, sorry, this is 2, or I will move little bit right here, otherwise it not be visible. So this is I am writing for LA1. NA1. Okay, right, that's why I'm writing here. So it's better to write, so this we understand, so I'm writing here so that it will be visible and I will writing will be quick. Okay, so I'm doing here. So if I write for NA1, then first its order is 6. After that xi is irreducible, that is 12 into, and this is irreducible yi is 1 and coefficient is 1, so 1 plus then this 0 into this is 1 and coefficient is 2. After that this 2, after that we will come here 1 and coefficient is 3. Okay, so you add it here now, then that is equal to 1 upon 6. This is 12, this is 12, this is 0 and 3, right? So this is 6. So this is going to be 12, 6, 18, 6 in the 3. So NA1 is 3. So similarly we will go for next NA2, again that is 1 by 6, and I will again start from here 12. Now I am doing this one, so 12 and this is 12 and this is 1, so into 1, sorry, first E 1, so 1 into coefficient also 1 plus, now I will go for 0 and this is 1, so 1 and coefficient is 2, and now I will go for this, that is 2, and I will go for here minus 1 and I will go for here into 3. Okay, so if I add it up, then 1 upon 6, that is 12, that is 0. Okay, this is 12, this is 0 and this is 2, 3 minus 6, so this is going to be again 1 because this is going to be 6, 6, 6, 1. Okay, so NA2 we get 6, NA1 we get 3. Now the last is NE. We will calculate for this. So first we will go for this first irreducible, so this is 12 and we are going now for this. We will do for other pen, yes, we are going for this. Okay, 12. After that this is 2, coefficient is 1 and 1 plus this is 0, so 0 of anything is 0, so I will not go for out. Now this is 3 and here it's again 0. Okay, this is again 0, I will now go for this is a whole become to 0. So this is going to give that how much, this is 0, this is 0 and this is 12 and 2, that is become 24 and 1 by here order. So that will going to give 12 3 jar 12 4 jar 24. Okay, so this is going to give 4. Okay, so what we get here 3 1 and 4. Okay, so we get this is 3A1 plus A2 plus 4E. Whether it is correct or not I will check. We will multiply it here 3, here 1, here 4. If we multiply it, then what is the value? This will become 3 3 3 3 and this will become same as it is 1 and this is become 8 and this is become minus 4 and this is 0. So add it. Now if you get this value then it's correct, otherwise wrong. 8 1 9 10 11 12. Okay, 12 we get here. This is plus 1 and plus 3, that is 4, minus 4, that is 0. Okay, this is we get. Now this is 4 and this is the, sorry for that, this is 4, this is 0, right? Because this value was 0, so this is again 0. So 3 minus 1, that is actually 12, 2. Okay, 3 minus 1, this is 0, right? If we multiply by any 0, then again 0. So 3 minus 1 equal to, because this value was previously what? This was 2, this was minus 1 and 0. So if we multiply by 2, then it will get 8. And this will get minus 4. And this is 0, 0. So this one 3, 1. 4 minus 4 0, and this is 3 1 4 4 8 12, and 3 minus 1 2. So same value we are getting as it is. So our answer is correct. So in this way we will reduce the reducible representation into irreducible representations. So the formula is right. So if that any in questions what will given, that let's say for C3v, then it's C3 P sigma b, and its reducible representations will be given. Let's say for this value is for reducible representation, that is how much? 3 and that 12, and this is C3, this is if I say C3, then that is 1, and this is minus that is 0, and this is 2. Okay, 12 0 2, and this will given to you, this will given, and also this is also given to you. This is the reducible representations, and this is also given to you. This is A1 A2 E 1 1 1 1 2, and this is 0, and this is 1 minus 1, this is minus 1. This is given to you, these tables and these tables given to you. Now ask that calculate irreducible representations. So this is also, this is irreducible representations. Okay, now from here we will calculate the irreducible representation from here to here, that this is the reducible representation. So this can be reduced, so that we have to calculate the irreducible representations. So if we reduce it, what we get, that values we will get here 3a1 plus a2 plus 4a, this we get. So this will given, and this also given to you. From here we calculate the irreducible representations. So we will calculate this one. Okay, how you calculate? By using the formula, that is formula is any irreducible representation is equal to 1 upon order, and here n1, this 1 2 3 like that, and xi, yi, and zi. Okay, so this xi, yi, and zi, xi represents irreducible representation. This one, this irreducible represent, sorry, this irreducible representation, and yi represent this irreducible representation given to you, and zi is coefficients of symmetry elements. So these things will given to you, this given to you, and calculate the irreducible representations. So you use these formulas and calculate it. Okay, so today after this, thank you.